Hello guys, welcome to the new video again. In this video we are going to discuss some new topics. So first would be normal forms, alright. So normal forms. So there are two types of normal forms in logic. First is principal disjunctive normal form, and second is principal conjunctive normal form. Right? So logic terms. In logic terms, two types of normal forms are there. Principal disjunctive normal form, and second is principal conjunctive normal form. So in Boolean algebra terms, we can say this canonical sum of product or min terms, and for this canonical product of sum or max terms in Boolean algebra form. Alright. So let's say, for example, sum of product in Boolean algebra f a comma b is, let's say, a plus b a. This is product. This is sum of product. Alright. So some what we can say, what is missing from here? Uh, b. So we can do is b plus b bar, which makes it 1, and b is already here, is equal to ab plus ab bar plus ba. So in this is canonical standard form. So in which all terms, all variables are uh, present in all terms. So the term 1, term 2, term 3, 1, 2, and 3, all variables a and b, both variables are present in this. This is standard form, right? So we can say in logic terms, you can represent it as like FAB, let's say FA union B and A, alright? And this will go like A and B, or A and B bar, or well, this is B and A B are same, so this would be like this, AB plus AB bar. We don't keep duplicates in one expression, alright? So this is what principal disjunctive normal form. Disjunctive means what is disjunctive is like this, alright? So principal is this. Sum of this represents sum. We can say this, or product represented by this, right? Or dot. Alright. One example for you guys is one example is A drives B intersects C complement. Alright. So biconditional C complement. So biconditional we already know B biconditional C is equivalent to C biconditional B or B XOR C equivalent to C XOR B, and this is equivalent to X naught, but B XOR C complement is equivalent to B XOR C. This is finding differences. Alright, this is equivalent to this, but this is finding similarities. Alright, as we discussed in the earlier lecture. So we can what we can say simplify this as A implements B XOR C. Implement can be like this: A plus B XOR C, because PQ is P bar plus Q. Right? This is how, and we can we can minimize this also with the help of Boolean algebra and principal conjunctive normal form logic. So next we will discuss principal conjunctive normal form logic, canonical product of some POS. Right, this is similar conjunctive product. Product means this, and sum is this. Principal is what? Conjunctive. So conjunctive is this conjunctive. Uh, so for f x comma y in Boolean algebra x dot x plus y, this is POI, product of sum. Right? And to simplify this, we can use x plus y bar, and x plus y. Like this, we can simplify this always. Right? And this would be x plus y bar, x plus y, and simplifies x plus y, x plus y bar. This is can extended canonical form. Right? This is distributed law here. Plus is distributed over canonical principal normal form must contain every variable in every term. Alright, this is the principle. Property is in n variable to. So some properties are there we have to follow. If n variables wells, then 2 to power n min or max terms available, and 2 to power n functions or number of tables, number of truth tables are possible. So this is a very good, you can say, question and note, very important here. Right, let me mark it also. 2 to power n. All right, then x y variable. For example, this is an example also. Variables are x comma y. Then possible of functions are x y bar, x bar y, and x y, x bar y bar, x bar y, x y bar, uh, x y, comma x y plus x bar y bar. Okay. This is also possible. X bar y plus x y, right? And further would be x bar y bar plus x bar y, comma x bar y bar plus x y bar, comma x bar y plus x y bar, comma x bar y plus x y, comma x y bar plus x y, comma x bar, comma x bar, comma x, comma y, comma y bar, comma x plus y only, comma x bar plus y bar. So these are all possible uh, possible many times and next time for 2 to the power 2 to our n would be 2 to the power 2 to the power 2 2 to 4 16 min terms, min or max terms. All right. Topology contains 2 to the power min terms. And one note also here is uh, note tautology contains 2 to the power n min terms for all n number of proposition variables. So tautology contains 2 to the power n min terms for all n where tautology 0 max term and tautology is 0 max terms. In tautology there is no max term, and contradiction contains 2 to the power n max terms and 0 min terms, right? And one more thing is contingency contains 1 to 2 power n minus 1 min terms, and also 1 to 2 power n minus 1 max terms. Alright. So one more note thing is n variables is 2 to power n functions from which one is tautology, right? And one is contradiction, and 2 to power 2 n minus 2 are contingencies, right? And proposition variable probability of randomly. So some examples are also here, like some questions are there. But first we will understand contingency contains 1 to 2 and many times. Why? And alright, why is this? Contingency contains 1 to 2 and minus 1 many times and contradiction to 2 and next times. So we will try to understand this. Diction contains 2 to power n next terms. And why? Because it is always false. So how many functions are there? It is always false for with n variables. One is the function, but how many terms it would contain? To the power n terms. Is it? Which is max terms only. So also one thing not clicking. So let's take the help of AI. I think this will be good. So why tautology contains 2 to the power n terms and contradiction contains 2 to the power n max terms and discrete logic. Yeah. So let's discuss this. In discrete logic, tautology proposition that is variable true regardless of the truth values of its variable. Since the tautology is true in all possible scenarios, it contains all two-term minterms, where each minterm corresponds to a unique combination of truth values for the in true all possible scenarios. It contains all two power n minterms, where each minterm corresponds to a unique combination of truth values for the n variables involved. Each minterm is a product and operation of literals that result in the value true. Right. On the other hand, in contradiction proposition, one of the value is so it contains one maxterm because each maxterm corresponds to a unique combination of truth values that could make a proposition true. But since the contradiction or next time true false. Sum of literals that result the value false. Fact that there is a two possible combination of truth values for n variables. The result can be either true or false. Therefore, if tautology covers all possible cases where a possible can be true, and the contradiction covers all possible values, all would be true. Reason why actions are associated with or maintaining actions respectively. Minterm is important parts of Boolean algebra. Minterms and what is minterm? And now I was not expecting this. Minterm exterm. Unless the terms of product of a little currently exactly once. I am to install this now. Should I take the question to different? Let's go for perplexity, where knowledge begins. So, a minterm is a product of literals that represent the smallest possible truth assignment for a given set of variables. For example, if we have a Boolean function with three variables a, b, c, and like this, in general, for n values there are two minterms. Diction is a product of literals that represent the largest possible truth assignment for a given set of values. For example, if we have a Boolean function with three variables a, b, and c, the contradiction would be not a and not b and not c. In general, for n value to choose contradiction, there is visible. No, this is not the answer actually. This is failed right now. We will go for chat GPT, I think. So we should go for chat GPT. This is not the right answer here. So let's discuss like here. Right. Basically, the tautology is a statement that is always true and regardless of tautology is a variable. Contradiction on the other hand is a statement that is always false regardless of the. To understand why tautology contains two arguments and next consider a truth table with n variables. For a tautology, every row of the truth table evaluates the to true. So every combination of input variables results in minterms that evaluates to true. Since there are n variables and each variable can take on either true or false value to a possible combination of input value. Therefore, in terms of a tautology. Alright. For a contradiction, every row to table evaluates to false, so every combination of input variables in a next term explanation for conditions than variables. This is very important here. Zero minterms. What we can write here is n variables for n max term max 1 Right. So how is this possible? I'm not understanding still. So I will go and watch a video. So which is going to Brave browser. Share my understanding this. And right, this is okay if I'm not understanding this clearly. No, this is wrong. We total contingency and satisfiability. Right. This is not helping me anymore. Is it amitkhurana here? amitkhurana. Logi. Video. Not a video here. Sorry guys. Thank you so much. I hope you understand. I am not understanding, but I hope you will understand this. One is two contingencies and oh, I do this. Alright, guys. Thank you for watching the video.